All right, so to solve f1 of x equals f2 of x by algebraic methods and graphing. So this is, maybe you have these instructions. So you have two functions and you want to know where they're the same at. So what you do with this is, algebraically, is very easy. You set them equal to each other. So negative 2x minus 11 is the same as 3x plus 7. We want to know where they're going to meet at, basically. And so when you solve that, it's just like normal, minus 3x, minus 3x. Get your x's left, get your numbers to the right. Pretty simple there. So negative 5x equals negative, or positive 18. And so x is going to be equal to 18/5 negative, or x is going to be equal to, looks like negative 3 3/5. And so or negative 3.6, I do believe is what that is. Okay? Then you plug that in to figure out what y would be. So we've got x. Now let's plug it in and see what y would be in that case. So and you can plug it into either side. It should come out the same. So if we plugged it into the f of 2 side of negative 3 3/5 equals 3 times negative 3 3/5 plus 7. And just go ahead and solve that. So equals, I'll just keep going down. So negative 3 3/5, I don't like that. I'm going to go back to 18/5 so I can do the math quicker. And so 18, so you got negative 3 over 1 times negative 18/5. 18 is 4 for 24, 3 for 54/5 plus 7. You know, if you just, I'm doing it by hand. You probably have a calculator, and we're done a long time ago. Over 35/5. And so opposite signs you subtract, and 54 minus 35 is 4, 14, 19, so negative 19/5. So we know they meet at negative 18/5 and negative 19/5, and you could check that on the other side as well. And I'll kind of do it over up above. So it equals negative 2 times negative 18/5 minus 11. And so you follow the work on this one, and you'd have positive 36/5 if you multiply it across. Hopefully I'm not making any arithmetic errors. Over 11 over 1. Common denominator would be 55. So now you've got 36/5 minus 55/5 for common denominator. And when you check that, 36 minus 55, or 55 minus 36, again, that's 4, 15, and 6 is 19. Imagine that. 19/5 negative. And so we know, we've kind of verified algebraically. I apologize, it's not very organized. You definitely need to organize that better than I just did. But your answer where they meet is negative 3 3/5 and negative 19/5. Okay, so now the second part of this is to see verify it algebraically. So I've opened up GeoGebra, and we'll just go ahead and verify this thing algebraically by typing it into the input field at the bottom. And so the first one is f at x. So f at x equals negative 2x minus 11. We'll plot that. It may or may not appear on our graph, but there it is. And the other one is, we'll call it g at x. So I don't have time, I don't waste time putting in f2. So g at x is 3x plus 7. And hopefully I entered them correctly. And that one appeared. And we're just going to go see where they meet. Let me zoom out here. Would probably probably be. Oh, I went the wrong way. There they go. So there they meet, and so we'll just put that point where they meet, they intersect at. Intersect two objects, I'll click on the first line and then the second function. And there they meet at negative 3.6 and negative 3.8. And so we have verified 19/5, negative 19/5 is negative 3.8. And so we verified that that's the correct answer. So there's the graphics side, there's the algebra side, so good luck, hope that helps.